So I'm here to introduce myself for a change. My name is Pieter. I'm now first listed. You had yourself listed as
No,
first
no,
author. Well,
never.
anyway, I work with John Benjamin's Publishing, and that's a scholarly publisher producing about 80 books annually, collective volumes, monographs, reference works, occasional dictionary. The BBI dictionary used to be a great success when people bought books. We also publish journals. Journal articles are still a big thing, fortunately, and we have some online resources. We focus on the humanities and mainly linguistics. Linguistics is about languages, and languages have become a lot easier in terms of Unicode support over the years, but still have some very difficult stuff sometimes with glosses and multi-line lineups, speech representations. And of course, we have occasional tables to format, but that's for any publisher a big deal. Since, well, Donald Knuth already said that tables are always a problem. Now, sometimes we also publish a book that contains programming code. And the last year, there was a book on R, or using R Studio for corpus linguistics. Oh yes, I should also mention that we're using an XML first workflow. So we usually take in Word, occasionally LaTeX, and convert that to XML, JATS for journals, BITS for books, and first try to sort of sort that out, and then produce PDF, ePub, and occasional web rendering. So this is the process, and that's the book we had at hand. The author said, I want absolute care that the programming code is presented well. He had bad experiences with publishers that made a mess out of it. He used many colors to identify the various syntax parts of the R code. And we at our side have obligations to provide ample contrast. And sometimes you see in our suggestions for slides that it's good to have good contrast so people can actually read what you're about to present, especially with this type of overhead projectors. But in publishing, it's becoming a legal obligation. So we took great care at producing the code or reproducing the code in XML. But if you have these colors in Word, then you can read the code. And if you have colors in XML, you have to put tags in between letters or symbols of code, which is extremely messy. Therefore, and also the author uses a code editor with syntax highlighting, and it's not a problem for code editors to produce colors. So why is it a problem for publishers or for publishing systems to simply also have code highlighting? So I asked Nico, what are we going to do about that? So Nico, now it's up to you.
So what are we going to do? Here's a code block in JATS. This is the definition from the website. And what we got as our input in XML was, well, it says there that it may contain elements for syntax coloring, which we did not have. We had PC data, parsable character data, so that's just the code. And there was some named content for additional comments inside the code blocks, which will be a challenge later. So we don't only have text in the code block, we also have embedded XML. Here's an example. This is what a code block looks like. The language is R, language version, and then we have a lot of R code. It's many years ago since I used R, so I kind of vaguely remembered it. here you see what it should look like, and this is what we had as an input. And that's okay, we just have code and it ends at the end. There's some named content here for the output, so we need to separate that from the rest. This is a slightly more complicated example because here the author has a regular expression pattern, but because it's complicated, like all regular expressions for some people, he made additional comments in the named content element. But these are separate from the regular expression. You can't put them in the regular expression because it will be a very different regular expression. So they should be formatted as comments. But in R, as in most other languages, you can't have these kind of comments in regular expressions. I think you can do that in Perl, though, but not here. So in order to use syntax highlighting, when Pieter asked me this, of course we were in a hurry. The book needed to be published. So I looked for code on GitHub for syntax highlighting for R programs, and I found this this project Highlight.js on GitHub, and it uses regular expressions. So I took the regular expressions. You can see them here. I made a few XSL variables. Actually, it's a lot more than this. So these patterns come straight out of the Highlight.js project. And then, of course, you can do analyze string. And it worked. That was the good part. It sort of looked okay. It was similar enough to what we saw in the Word file. Of course, I knew from the beginning that regular expressions are not as powerful as an actual context-free grammar. But since we're not doing syntax checking, only syntax coloring, I thought it's not much of a big deal. Some things cannot be parsed correctly, though, and we'll see a few examples. And also the code is not very elegant. So here in the analyze string, I have put all the regular expressions together into this $R match RE. It's one huge regular expression, which already is not such a good idea. And then if something matches, then I figure out, okay, which part actually matched. So I have this matching substring, and then I choose, is it a comment, is it a literal, etc., etc., etc. And then when I found something, I call this function r-styled content. So then I say this should be a comment, and then I generate a span element with a class of comments. Actually, we used this because we were in a hurry, and it was good enough. But of course, it's not good enough. And also we thought next time we should be better prepared because other authors may use other programming languages. How are we going to deal with that? So later I looked for a grammar for R. I found this BNF grammar on GitHub, and I converted that into ixml. And it's about 350 lines of ixml. And I found a few small errors in the grammar. So the grammar that I found on GitHub is obviously not what the R compiler is using. I don't know what they use because I couldn't find it. Maybe one day I will. So I have lots of expressions like the one in blue here. A program is spaces. The underscore is spaces because that's what they used in the original BNF grammar. And then there's an expression or assignment. A lot of them separated by prog separators, and then there's more spaces. So I can show you what the grammar looks like. This is the file which is on GitHub. A link will be in the proceedings, in the slides. So this is the grammar, and it just goes on and on. It's almost a literal translation of this BNF grammar which I found on GitHub. And it goes on further, etc. Well, there are a few things that you might recognize here. And you can read this when you can't fall asleep, maybe. So I fixed the errors. What I found out, and that's something that Stephen also said yesterday, spacing is very tricky. You need to put the spaces in very particular spots, otherwise your grammar will be very ambiguous and parsing will take much longer. So I put some effort into that. And then actually I ended up with quite elegant code. So here are the 2 lines apart from the grammar. So I say that the grammar is, I need to read it from a file, the r.ixml file. And then I say, okay, this could have been invisible XML. I use transparent invisible XML, which I'll come back to later. It's something I spoke about at XML Prague this year. And so we have a parser, which means I just compile the grammar, and then I've got a parser, and I can parse these code blocks, and then I have a lot of XML, which is very nice, because then I can easily generate spans for the HTML using simple XSLT style sheets. Unfortunately, this was not the solution we ended up using, because this was later. The book was already published, but at least we're prepared now for next time. There were several problems. One is ambiguity, which Stephen also spoke about yesterday. And in R, there's a very particular ambiguity, which is assignment. So here I have the expression x less than minus 37. And it can mean 2 things. It's either an assignment, assign 37 to the variable x, but it can also be a Boolean expression testing whether x is less than minus 37. And it's not clear from the grammar of R what it should be. The R compiler solves this by first doing a lexical analysis, using something like lex probably, and then it uses YAC to generate the compiler. And then in the lexical analysis, it parses all the operators. So you already know whether it's an assignment or a less than followed by a unary minus. But I only have ixml, so I can't do that. This is a nasty problem, because I found out about this by trying it, and I didn't get assignments. I got these Boolean comparisons, and I thought, what's wrong? And the ixml parser generator markup blitz that I used just happened to choose the less than operator, and it couldn't parse the assignment. And since there were lots of assignments and no comparisons with a negative number, it was always wrong. In ixml at the moment, it's not possible to say, use this one over the other possible ambiguous parsing. So I had to solve this, and I just made a pre-processing step, like lexical analysis. I had an XSLT style sheet. It looks through all the text nodes, and then it transforms less than minus into a Unicode arrow, a left-pointing arrow. And that works. After parsing, I just transform this back into less than minus. So here's what I do. This is the code. So I get this replace. And then this is the pre-processing, this first template. And the post-processing is the other template. So this is really a very simple action to do. And it works. But it's not elegant. It works.
Nico, it doesn't work if there is an actual arrow in the text.
It doesn't work when there is an actual arrow in the text.
You'll unconvert it.
I know. Let's just say that never happens, okay? If that happens, I need to do something else, and that's right. And there are several options that you could consider. But yeah, indeed, you always have another kind of ambiguity. So then we have this other problem. There's embedded markup that's not part of the R code. That's in the named content elements. And this is a bit more of a serious problem. So here's an example. Again, this regular expression pattern where the author has commented upon parts of the regular expression pattern. Like if I have this pattern is, and then parenthesis, question mark X, it means set free spacing. apparently. And then the next line is everything from beginning to the first curly brace, etc. So what we need to do here in order to do the right kind of syntax coloring for R is we need to ignore everything within the named content element because it's not part of the R code. We don't need to syntax color it. And later we'll see that the regular expression version does actually apply syntax coloring to these comments, which is wrong. So what we should do is take away all these elements and their content, but then, we could do that, but then you've lost it. And these comments will not be displayed, and the author will be angry at us, I think. Yeah, he will be. So what we did, here you see the invisible XML. Oh yeah, there's problem 1 or solution 1. iXML cannot deal with these embedded elements, so I use transparent invisible XML, and what that does is the parser does not just parse a string, but it parses XML nodes, and there can be elements inside these nodes. So here's the updated function signature for transparent iXML, and you can look at this presentation at XML Prague this year. And then we have another problem, because what transparent iXML does is it ignores the XML elements, but the text embedded within these elements is kept. So you get something like this. Forget about the gray named content elements. Now you get the author's comments right inside this regular expression. And that will certainly produce syntax errors, because this is not correct R syntax anymore. So I also solved that with more pre- and post-processing. So basically what I did, I take the content of these named content elements, I serialize it into an attribute of the named content, I take the actual content out, so it's ignored by the transparent iXML processor, and then later I unhide that content by taking the content attribute and parsing it and putting that inside the named content element. So you can even have XML elements embedded within the content of the named content element. So what are the advantages of using iXML and transparent iXML over regular expressions? Well, it's the readability of the code. The regular expressions for syntax coloring very quickly become really hard to read. And in the iXML solution, we have the grammar separated from the code, which is a huge advantage, I think, because you have a separation of concerns there. And also you can introduce non-terminals, lots of them. We have more than 85 in our grammar that are actually used, which means you get a meaningful XML representation instead of just, yeah, I've parsed something that looks like a comment, that kind of thing. Accuracy is a lot better, because a context-free grammar is a lot more powerful than a regular expression. And there are indeed some errors in the highlighting produced by the regular expressions, which we'll see in a minute. Also, syntactic detail is much better. We ended up using 12 regular expressions, and that's about the number you can more or less easily handle. And I think there were maybe 2 more in the original Highlight.js regular expression set. And here we have 87 non-terminals. A few of there are actually more, but I minused them out because they're not interesting, so we don't see them. So you could potentially have a much more fine-grained syntax highlighting. The disadvantage is it's a lot more work, because if you want to do syntax highlighting, you only have to come up with some regular expressions for the parts that you actually want to highlight. Here we had to come up with a grammar for the complete R language. It was good that there was already a BNF grammar, but still it took me, I don't know, 5 or 6 evenings of hard work to get it all right. Good, it's time for the demo. Let's see. I'll go here. So this is on GitHub. Over here, can I scroll? Yeah, so you can see this in the proceedings. So what I've done, I have several fragments, several code fragments. This is the original, and we've seen this before, I think. And this is the result when parsing with a regular expression and doing syntax highlighting. So there's also CSS style sheet and some XSL transformations. And this is what it comes up with, which is pretty okay. And in fact, if I use the ixml version, you can see that nothing changes. So this is really identical, the result, which we get out of this. So when I go a bit further, here I have a comment in the R code. So I'll show the original. This is a normal R comment. Everything after this hash mark, as it's nowadays called, is a comment. And if we look at the regular expression version, it's recognized as a comment because it's everything from here running to the end of the line. And if we look over here, there's a difference. So what's the difference? Well, here you see that the plus is recognized as a string. Now there's this funny thing in R. If you use a string like this, and it's followed by function arguments, it's actually a function. And because we have an actual grammar, we can recognize this correctly as a function call, which is the same as the string plus. And this is the way how you can actually define binary operators in R. So this is already a bit better, and it produces a subtly different color, but it's hardly visible, I'm afraid, on this screen. So then we have the named parameters. This is the original. Named parameters are things like list equals this, all equals true. And this is a regular expression version. And I don't think a lot changed. Yeah, there is some change here. Which we don't recognize the is as an operator because it's not. It is just part of a named parameter, but in this location in the program, it's not an operator. Or actually, do I say, yeah, it's the other way around. Sorry, it is an operator, but it wasn't recognized by a regular expression, of course. Anyway, this is how you define the grammar. I'm not an R specialist. Here, okay, now we have these named content elements. And if you look at the regular expression version, this is for output. I'll go back briefly. So here we have named content, the content type is output. So when you evaluate this expression, this should be the output. And okay, it's recognized fairly well, and it's the same in XML. There was a problem. What was the problem again? I'm just coming from the control room, so my head is really messed up. Oh yeah, it's the spaces. That's the problem. The spaces are here in a different position, but I need to scroll down. Anyway, spaces are a problem here for the regular expression because they don't show up. I forgot. But let's go to the next example. This is all online, by the way. So here we have another output. And the regular expression version does this fairly well. There's no change. Okay. Actually, I made this program in xquery, running in exist, just to see how the XML version compares to the regular expression version. So this is just a subset of all the tests that I had to do in order to check whether I was doing things in the right way. Oh yeah, now we have the dollar operator. And that's used for variable extraction, like here the $P1. And the regular expression, I think it just, does it recognize it? Let's see. It says identifier. And here it says identifier, so that should be okay. again. So you see there's not always a difference. And now we have words as a parameter over here, but it isn't. So the regular expression thinks that this is a named parameter because it says words equals. But of course, if you parse correctly, you see that it's an equality comparison equals equals. So here, if you look very closely, this equal sign is subtly different from this one, which is a bit thinner. It has a different color, but it looks thinner over here. And it says here parameter. And you can see that here, the words is a parameter. Where's my cursor? It's gone. There it is. Words, parameter equals, and then we have another operator equals. So regular expression can't parse this. And here we correctly have this as a one operator equals equals. And it should be, yeah, here, equals equals. So in this case, if this parameter would have had a different color from just a variable that you compare with some value, this would have gone wrong, but the author hasn't noticed so far. I hope he's not watching. And then we have this named content inside of this regular expression pattern. So it's this pattern over here, and the regular expression parser. Okay, looks good. But it matches things here. Actually, you can't see it, but it does somewhere. But I forgot where it is. Let's see, is there, I don't see a difference, but in here, if you look at the generated code, it is different at some point. Anyway, the point is we can actually parse more correctly with ixml. It is better code that we get, and if we ever get a book with program code, we just have to look for a grammar which we can translate to ixml.
I'm thinking these code editors use some JavaScript tool to generate highlighting. They might even also benefit from a grammar-based approach. So it's not necessarily confined to XML or to publishing. It's, we should think broadly. So actually, this is a proof of concept, but I think Nico has convincingly shown that it would be useful to take this approach. Do you agree?
Yeah.
Okay.
So
well,
here's some links. Actually, I think this grammar for R is one of the largest ixml grammars I've seen online. I don't know, Stephen, 350 lines, is that a lot?
Yeah, that's quite a lot, although... 350 lines is quite a lot, although I recall that John has done XPath, and that is very long and convoluted. So.
Yeah. Also, it is quite fast. Of course, it depends on your parser generator. We've used markup blitz, which I have adapted for transparent invisible XML, and then I've integrated it into exists. That was also a lot of work, but I'm glad I did it because now I can do all sorts of things with that. And it performs very well, actually.
is that available to others?
Yes, that's the first link is about this talk. It contains all the code that you can put into exists. It's just a XR file, so you have to import the package, and then it just works. And then the second one is the code for the XR file. So you can also change that if you want. It does transparent IXML. Actually, it's not just IXML. So there are two extension functions, one for normal IXML, one for transparent IXML. And then the third reference is if you are interested in JATS and how this whole thing works, you can look it up there. So it is available, yeah. And I think I've even put in some documentation this time.
Thank you.
So I think, if I understand correctly, you started off with the ambition of syntax highlighting of R, but you've actually built something much, much more powerful than that.
Yes, I think so.
So it wouldn't be too much harder to take your markup that describes R and actually evaluate R directly. Just a thought. Or produce a linter.
Yes, I
like
think that would
so.
be feasible. Actually building an R interpreter,
I don't think it's so much further
I think
to
it's
go.
feasible too, yeah.
Maybe another fun project.
Yes, it might be a
Thank
fun
you.
project. And actually this might be useful for some kind of interactive books, because publishers have to come up with new ideas in order to stay relevant. And then this might be like an integrated R notebook in the book. And I think that would be very useful indeed. Yeah. Yeah.
There's one little thing I would like to add, because at some point after we prepared all of this, Nico said, I looked again at the Word document, and all those tags in the Word document actually contained structure and some labels that we could have used. And for a very short time, I thought that might have been a good idea. But if you look at some